All right, we're going to start here with number 14. Calculate the number of molecules present in 4.29 grams of nitrogen dioxide. 4.29 grams of NO2 is the formula. It's a covalent compound. It's got two or more nonmetals bonded together. The molar mass we would need to calculate from the periodic table is going to come out to be 46.01 grams of NO2, and that allows us to go into moles. Now, from here, we're going to go moles into molecules, because that's what we're looking for. For every 1 mole of NO2, I have 6.02 times 10 to the 23rd, and I'm going to abbreviate molecules MC of NO2. When we calculate, final answer, 5.61 times 10 to the 22 MC molecules of NO2. Number 15, calculate the number of moles of sulfur atoms present in 2.01 grams of sodium sulfide. We're looking for moles, specifically of sulfur atoms, in 2.01 grams of sodium sulfide. 2.01 grams of Na2S. We're going to use the molar mass to get into moles. 78.05 grams is the molar mass of Na2S, found from the periodic table. 1 mole of Na2S, that is our molar mass conversion. But here specifically, we need to get into moles of sulfur. So here's what I'm going to do. It's called the mole-to-mole ratio. 1 mole of Na2S, if I have 1 mole of that compound, how many moles of sulfur atoms do I have? In this case, it's a 1-to-1 mole ratio. In every 1 mole of Na2S, I have 1 mole of sulfur atoms. So I don't need the 6.02 number here. When I calculate the final answer, 0.0258 moles of sulfur atoms. I'm not counting atoms, I'm counting moles of sulfur atoms. I could go into atoms specifically, but I'm not here. Number 16, calculate the mass in grams of 2.49 times 10 to the 20th carbon dioxide molecules. I'm looking for mass, so I'm going to have to use a molar mass most likely. Here's how many molecules I'm starting with. 2.49 times 10 to the 20th molecules, MC, of carbon dioxide, CO2. Some formulas we're not going to give you. CO2 may not be one that we give you because it's so common, but if it's something like sodium sulfide, we would provide that to you. In Unit 6, we're going to learn how to actually write and name compounds. There are 6.02 times 10 to the 23rd molecules of CO2 in every 1 mole of CO2. I'm looking for the mass, so I need the molar mass. For every 1 mole of CO2, I need grams. So from the periodic table, I would add all the masses together, 44.01 grams of CO2. Final answer, 0.0182 grams of CO2. Number 17, calculate the grams of carbon, specifically in 12.2 moles of sucrose, C12H22O11. I'll start out with 12.2 moles of sucrose, C12H22O11. I'm going to go ahead and get into carbon because I really don't want to calculate the molar mass of sucrose. That would take me a while. It's okay to use a mole-to-mole ratio right at the beginning. For every 1 mole of C12H22O11, you have 12 moles of carbon specifically, because there are 12 in there. From here, I'm going to go for every 1 mole of carbon. Now I can use my molar mass just of carbon. It allows me to shorten the process just a little bit. 12.01 grams for carbon specifically. Final answer, when you calculate, 1760 grams of carbon. Okay, our last conversion, we have three major ones here. This is going to be converting into volume. So we've done particles, like atoms, molecules, ions, formula units. The second conversion we used was molar mass, where we actually have to calculate that conversion factor on the periodic table. The third one is right here. This is molar volume. Specifically, I want you guys to note this, of a gas. We're talking about gases here. When we start to have volume of a liquid, we're going to use something called molarity, which we're not quite there yet. So this is specifically of a gaseous substance. We measure the value of the volume at two parameters. Number one, the temperature. So we call this the standard temperature. It's 0 degrees Celsius. And we also measure it at a parameter of pressure because gases are affected by pressure. So 0 degrees Celsius and 1 what we call atmosphere, ATM. These values make up what we call STP, the standard temperature and pressure. At STP, 1 mole of any gas takes up a space of 22.4 liters. It doesn't matter what substance it is. If it's a gas and it's at those conditions, it's going to take up 22.4 liters. We call it molar volume of a gas. It's equivalent to 6.02 times 10 to the 23rd representative particles of the gas. And 22.4 liters of the gas is going to have a mass that's equal to the gram formula mass, or the molar mass. So everything's connected here, 22.4, 6.02, and molar mass. So this is our new conversion factor. For every 1 mole, specifically of a gas, we're going to have 22.4 liters of that gas, whatever it may be. Number 18, what is the volume in liters of at STP of 0.960 moles of methane? So I'm going to use my conversion, 0.960 moles of CH4. That's a gas, methane. For every 1 mole of CH4, here's my conversion, 22.4 liters. That's called molar volume of a gas. When we calculate, final answer is 21.5 liters of methane. At STP, how many moles are in 0.542 milliliters of neon gas? 0.542 milliliters of neon. So the first step, molar volume of a gas is 22.4 liters, not milliliters, so we're going to have to convert. There are 1,000 milliliters of neon in every 1 liter of neon. And if you need to refresh, King Henry died unusually drinking chocolate milk. You might need that conversion. 10 times 10 times 10 is a factor of 1,000. And then we're going to use our conversion. 22.4 goes on the bottom because liters need to cancel for every 1 mole of neon gas. When we calculate, final answer, 2.42 times 10 to the negative 5th moles of neon gas. Okay, and then we're going to mention density because now we have volume. If we know the density of gas, and I want you to box this in grams per liter, not grams per milliliter, because molar volume is 22.4 liters, we can calculate the gram formula mass of the gas. So we can actually convert from density into volume into grams if we need to. So the molar volume times the density is going to equal these conversions right here. 22.4 liters per mole, that's our molar conversion for gas. Here's our density. And what it's going to give us is the GFM of that gas. So we're going to calculate the density here of sulfur dioxide gas at STP. So SO2, on the periodic table, if I calculate the molar mass, it's 64.07 grams per mole. So I'm going to set this up, 64.07 grams of SO2 I'm going to go ahead and set up a t-table to show you how I do it. Now, this is a molar mass, so it's per 1 mole of SO2. And then I'm going to use the density to make sure that my units cancel. My molar volume. 1 mole of SO2, and I'm going to go into 22.4 liters. So what happens with units? Moles cancels, top and bottom. I'm left with grams over liters, which essentially I get a density. 2.86 grams per liter of SO2 gas. Now, could you convert that into grams per milliliter? Of course, but we're going to go ahead and leave it there for this problem.